All right, thank you, Marco and Lutz, and let's get going here. So we're here now to talk about modernizing your ancient 4GL coding habits, or dragging your code kicking and screaming into the 90s, which may not seem all that modern, but hey, we'll go with it. So for those who don't know, White Star Software is a consulting organization. We've been focused on Progress Open Edge since 1987. We happen to be the oldest independent consulting organization in the Progress Open Edge world. Our breadth of experience is very wide. We work with everyone from really small and chaotic customers to really big, demanding financial services and manufacturing customers. Basically everything that is out there we've worked with at some point or other. We do a lot of talking at Progress Users Conferences because we enjoy sharing our experiences with people and kind of spreading the good news of Progress around as far as we can. So I'm Tom Bascom. I've been using Progress myself since 1987 here at White Star. I'm the author of ProTop, which we're not really going to talk about in this particular talk, so I'm sure you're all relieved by that. But we do have this product called ProTop, which simplifies the job of managing and monitoring the world's best business applications. If you have any questions about this presentation, feel free to either ask them during the presentation via the chat if you're remote, or locally if you're local, or send me an email at tom@WSS if you're looking at this after, and I'll be happy to try and answer your questions. So with that, let's get going. So our agenda, we're going to work on a couple of topics related to modernizing ancient 4GL code. So mostly I'm talking about code that was written or started, where the initial phases of writing the code predate version 6 or even version 4 of Progress. Really, really ancient stuff, which, there's a lot of legacy code out there that either was written back then or was written by people who learned Progress at that time and who haven't necessarily moved their code forward. So there's some things you can do in your code that can help you be more modern than that V4 code. Some of that has to do with reading and writing files. Some of it has to do with simple things like using the substitute statement instead of building strings by concatenation. I'm going to talk a little bit about replacing global shared variables and things of that nature with object-oriented constructs, replacing can do with lookup, and then I'm going to give you some things that you should probably stop doing right away if you can. So here we go. Look at that, a duplicate slide. I didn't see that slide. Did you see that? No. Okay. So reading and writing files. There are a couple of things that have been introduced to the 4GL. Some of these are older than others, but the long char data type is a much larger variable than a string variable. A string variable can only be about 30K long, whereas a long char can hold text up to around a gigabyte. And you can get data into and out of a long char using copy lob. So you can copy from a file to a long char variable or the other way around, which is much simpler than the old style way of doing things where you had to open the file and then import it into multiple lines of text or maybe even a key at a time, depending on how long ago you wrote this code, where you would have a read key loop to read the file. And then you can process the lines in the file using num entries and entry 1, entry 2 with the new line character as your delimiter. Now there are some caveats. Long char variables may perform poorly, especially if you're using string functions on them to pick them apart repetitively, or if you're frequently appending data to them because they have to be reallocated over and over and over when you do that. So that's something to watch out for, but generally speaking, they're pretty performant. And I have a example here of putting together a simple text editor with a long char and a file. So if you take this code here and pass it a parameter, which is the name of a file, then the long char variable called file body, if it exists, will be read into the variable using copy lob from a file, checking to get the full path name of the file into file body. And then with this simple update statement here, you basically have a text editor on your screen, and you can edit your file using the usual editing keys and change the contents and so on and so forth. And then if you save it with F1 or Control X, your changes will be written back to the operating system. Or if you abandon it with F4, Control E, your changes will be abandoned. Very simple thing to do, but it shows the power of reading and writing files using copylog and long car to get that done. Much easier than the old school way of doing things with import. So that's one simple thing that you can do in your ancient code to bring it up to speed if you have any need to manipulate files. Another thing that frequently comes up is issues with building strings for various reasons in your file. And the old style way of doing that was to do a lot of concatenation. So you had variable this plus variable that, and you would build it up over time out of the individual pieces, field names and constant strings and things like that. A much better way to do things is to use the substitute statement, which allows you to create a template for your string and then substitute values into that. One of the really, really big advantages of that is that you no longer have to worry about polluting your string with an unknown value. Something that went wrong a lot in the old legacy code was if a variable or a field was unknown at some point and you concatenated that, or if the result of a calculation resulted in an unknown and you concatenated that into the string, then the whole string becomes unknown, which is a real pain in the neck. Another thing that often went wrong in that old code was if you were doing that within a loop, then you could get a string that's too long relatively quickly, especially if it was a recursive operation and you weren't carefully checking the length of the string. So the templated thing also allows you to more easily translate, so you don't have to be continually translating and putting :u on the end of all sorts of constant fields. It makes it a little simpler from that perspective. So your code becomes more maintainable, it's easier to read, you can do things with it like transfer it across multiple languages much more simply. You can even put the templates into database fields and then just swap them out for whatever your localization needs might be. Oops, okay, so we're going from substitute to shared variables. So shared variables are something that is one of the most widely used worst practices in legacy code. So way back when, Progress used to have a limit on the, I'm sure everybody wants to see that, a limit on the size of your R code. So there's a 63K limit on R code. And one of the ways to get around that was to partition your code into multiple procedures and run those procedures independently, passing the state between them with shared variables. Eventually, I think it was version 5, might have been version 6, Progress came along with parameter passing. But by then, most of the damage had been done, and many applications were using shared variables in place of parameter passing. And the problem with this is that it tightly couples your modules to each other. You have basically an undocumented interface. You don't have any of the input-output options that you do with parameters, and all the evils that we've learned since then about global scope and that. And then, of course, there's the problems of how do you unit test any of that kind of thing. Of course, unit testing wasn't really an issue. Nobody cared about that in the 90s. But that's a much bigger problem now. And these days, if you write some code using shared variables, well, you know, your friends and neighbors and colleagues are all going to make fun of you for using shared variables too much. So what do you do about that? If you've got a bunch of code that is using shared variables, you'd like to make it better. How do you do it without having to rewrite your entire application? Well, fortunately, Progress also has introduced something called object orientation. And this is eventually, in a couple of slides, going to get us out of this problem. So there are some myths about OpenEdge.io. A lot of people believe that Progress doesn't really support true object orientation. And my comment there is anytime somebody starts talking to you about true, when they're talking about a technical topic, is that you're having a religious discussion and you probably ought to just wrap it up and leave. You're not going to get anywhere with it. Many people believe that the object-oriented features are just for the GUI programming in progress, that they're not really useful in procedural code, that you can't mix procedural and object-oriented code, or that progress has done all that they're going to do from an object-oriented perspective, and there's nothing new coming along. And then there's always the problem of whether or not objects and relational databases mix. For our purposes, one of the big objections is that your application was written back when version 4 was exciting, so object-oriented features aren't going to apply to me. Well, the truth of the matter is that progress started on this 004GL journey back in 10.1a, back in 2005, and they've been doing a lot of stuff since then, and they're still working hard on it. There are new features related to object orientation coming out in every release. And those features work very, very well, regardless of whether you have GUI code, character code, web code, batch code. You can mix it all into procedural code too. And I'm here to explain how your version 4 app can take advantage of these features as well, or some of these features. So back to the shared variables versus objects. So the downtime of shared variables, one of the downsides of shared variables is that consistency, whether or not the data type is the same, isn't checked until runtime. So when you compile code using shared variables and you have a shared variable declared in one procedure and you want to reference that shared variable in another procedure, you don't find out if you called one of them character and the other one integer until runtime. And that's really kind of late in the game to be finding out that you made a mistake like that. The definitions have to match everywhere or you're going to get a runtime error. And of course, to work around that, people use include files. And include files are a danger all of their own, or kind of a worst practice of their own. Objects, on the other hand, have compile time checking. So when you reference an object, the data typing is enforced at the time of compile. You don't wait until runtime to find out that you have differences in the definition. And it encapsulates all the behaviors, so you don't need to have include files to help you out with that. There's a single implementation. There's just one one class definition that has the implementation of that object. So you don't have to look all over the place to find out how that object should behave. And you have very fine-grained control over privacy, protection, security. All the unplanned side effects are something that you're able to control with the object-oriented structures. So how does this help us out with shared variables? Well, you can use something called the singleton, which is a class that there's just one copy of. And you can create that by using a object that only has static properties and methods. So no database references, no data being held within it. So the class is basically at that point just the code. You'll find arguments if you look around, with Google and Stack Overflow and whatnot, that singletons are a bit of an anti-pattern because they introduce global state. But in this particular situation, we're not introducing global state. There's already global state in the application. We're just getting control of it because it's already there. So we're taking something that's already bad and we're making it better. We may not be curing the problem entirely, which would require a rewrite of your application, but we are improving things quite a bit by moving to a more modern way of doing things. So one of the key things about a static class is that you can reference it without actually instantiating it. That means that you don't have to add anything to your code like using or a new statement or something like that. You just code the reference to it. Just say, hey, here's an object. I'm referring to this object. And what that then leads you to is that to replace your shared variables, all you got to do is a global search and replace. So basically just search for the shared variable name, replace it with the object name. So we can create a class called global shared variable.class, gsv.cls. It might look something like this. And we give it a static property called cnum. That would be what we might have had for a shared variable name. And the get and the set are just very simple, except whatever assignment to it. And this will work just like a variable. That's all there is. It's just 5 lines of code, really. There's a couple blank lines in the comment, but the executable part of this is pretty trivial. And then if you look at how you would do this kind of code in the old style versus how you do it in the new style, In your old code, you had to define the variable, which you probably did in an include file. And then you say something like find customer, no lock, where custom equals cnum, no error. In your new code, you replace the cnum, the equals cnum, with GSV colon cnum, no error. Same code. Pretty easy to do, huh? You like that? I like that. I think that's really cool that you can do that. If you want to go even further, then you can get control over side effects, like whether or not somebody can make an assignment to that shared variables or your static property. So you could change the setter to be private. And if you do this, you could just make it private and say nobody can change it. Or you could make it private and provide a method for changing it. So now it can only be changed by people who at least know the method name. So you have created a public method. It's not the same as the variable name itself, but this allows you to get a little bit more control over who can do what and how they can make changes to your shared variable, which is nice because that helps you to reduce the potential for side effects, all without having to make major architectural changes to your code. Another usage of object orientation is to cache data out of the database. So you may have some DB fields. Now, why would you want to do that? Well, in a lot of these old applications, and a lot of new applications too, for that matter, there are control tables of one sort or another. They usually are very small, and they control things about the configuration or the setup of the application. The content doesn't change very often. It's read mostly, if not read only, and it tends to be very, very frequently accessed. And that's partly because of the power of Progress. You know, Progress was one of those languages that really changed the way people thought about things, because your data access was so smoothly and easily integrated with your coding. It was really, really easy to set things up like these control tables as part of the database and just to naturally store all that kind of stuff there, which was not such an easy, obvious, simple thing to do in code where you're writing with COBOL or C or Java or something like that. You just didn't think that way. Your thinking with a Progress application is to naturally, of course, I'm going to store data in the database, and of course, I'm going to reference these control tables as database tables. The issue then becomes, because they are so frequently accessed, in some cases, the little itty bitty teeny tiny tables are more data access than the rest of the application combined, and that can actually form a bottleneck. So if you can do something to improve that, like catch those fields, particularly when they're read-only or read-mostly, you can alleviate that bottleneck. So how do you do that? Well, you might write a caching class, something like this, where you have a property, a couple of properties here that help to control how frequently we update the cache. So one of them is the last check. So this is the last time we check to see whether or not we needed to update things, and then a TTL, or time to live, property. So basically what I'm saying here is every 15 seconds, we'll go check the database to see if this data has been updated. 15 seconds isn't very long. You could make it a lot longer. You could say maybe you only want to check once an hour, depending on what that data is and how frequently it might check. But the first thing you do when you're looking for the property, the cached property, which in this case is system name or sysname. So this might be maybe part of your licensing system where you have a name that's been defined for the deployed system. And of course, you're displaying that on every screen, and you're checking it whenever you're doing anything interesting in the application. So we're checking to see if the sysname is whatever it's supposed to be. And if the time to live hasn't expired, then we just return the value that we already have. If the time to live has expired, then we go and we check the sysconfig table to see whether or not the system name needs to be updated. So in those hundreds of times in 15 seconds when you reference that, you're going to get just the cached value. And then once in a while, you're going to get the up-to-date value. So that's a pretty cool way to do things. And obviously, you could put many, many, many more properties than just one sysname in here. This is a very very small, trivial example of that. And so here's a little bit of a test program to see whether or not that changes. So you can go out there and see what the value is, and then if it's been cached, then find out how frequently it gets updated. So that's kind of fun. Then there's can do. So can do is something that you know, a long time ago, when Progress didn't have any string functions, somebody noticed that you could take the security function called can do, and you could do a lot of interesting string operations with it, or you could sort of do a lot of interesting string operations with it. Things that are now done differently, but it got used in a lot of code that was very widely distributed. And there are some problems with can do, and Progress explains those in these K-base articles that are linked here. But basically, it's a security and user control function, not a string function. And there are some things about can do that are specific to its security usage that make it a real problem when you use it in code that is not involved with checking user IDs. Furthermore, the most straightforward uses of can do are really trivially replaced with use of lookup. So the biggest difference between lookup and can do, on the surface anyway, is that the order of arguments is in reverse. So can do has the list, and then it has the thing that you're checking against the list, whereas lookup has the thing you're checking and then has the list. And can do returns a true or false, whereas lookup returns an integer. But other than that, they're very easy to replace one with the other. In fact, in cases where you have literal strings, you could do this pretty automatically. You don't really even need to think very hard about doing this. But of course, the next argument that you get is, well, can do supports wildcards. And that's true. Can do does support wildcards. But most of the way that people use wildcards in can do could also be taken care of using the begins, the matches, or the compare functions. And it's fairly easy to write a routine which will give you the equivalent of can do's good behavior when it comes to wildcard, just like this. So basically, you're looking up whether or not there's a wildcard in there, and then also handling the negative case of that as well. And this will function much like people expect can do to function. And this will cover an awful lot of cases where you're using can do to do wildcard kinds of things. And while we're talking about wildcards, we should probably take note of the fact that the way can do does wildcards is not exactly intuitive. There are a number of things about the wildcards in can do that are not necessarily well known and that probably don't work the way you expect them to work. And it's even worse if you allow users to enter arbitrary data into the strings that you're comparing. So there are some magic characters. There's the wildcard characters that you know about and expect, like dot, asterisk, exclamation point. The pound sign is used for grantable versus non-grantable SQL 89 permissions. So this is not anything that most people are expecting can do to treat as a wildcard or as a special character. And spaces are also problematic. You can't have spaces in your comparison strings. And in OpenEdge 11, Progress introduced a new magical character to can do, the @ sign, which broke an awful lot of people's code because they weren't expecting that to happen. And Progress quite rightly said, well, can do is a security function, and the @ sign is being used for security domains, and this is well within our purview to change that. So they did. Other quirks could be added at any time, really. So the Progress is not kidding when they say that you should not be using can do to do string comparisons. If you are, please stop. It's a security function. It will help you to produce bugs that you're not hoping to do. And then the worst part is, from a performance perspective, another little known thing, can do must be evaluated by the client. So there's no server-side execution of the can do function. All the data that the can do applies to has to be shipped back to the client So if you have a can do and a where clause, you're going to have a table scan, and all that data is going to be evaluated on the client. So really, if you need all those wildcards and you're not excited about my function that I shared with you there earlier, you might want to consider using a regular expression or something like that. Okay, then there's find first and find last, and for first and for last for that matter. Again, some very old code basically puts a first on every usage of find. And there's a lot of mythology around that find first is some sort of a standard or best practice, or that it always works. Well, none of those things are true. It's not a standard, it's not a best practice, and it doesn't always work. The find statement was created by, and this is one of Progress's great advantages over SQL, is the way the find statement works. Find statement is designed to return exactly 1 or 0 records. And almost all of the find statements in your code should be finding unique records with a where clause that identifies a unique record. And if it specifies a unique record, then there's no value to adding the word first. It does not, no matter how many times somebody tells you this, it does not suppress an extra find to find out if there's another record. If the compiler knows that that was a unique find, it will not check to see if there's another ambiguous record, because there isn't one. It was a unique index. And it confuses maintenance programmers by saying, hey, maybe there's a second one somewhere, or a third one, or a fourth one. It's not faster. You can run all these statements here that I'm showing, and you'll get the same result. It'll take the same amount of time. It'll do the same amount of logical operations. It'll do the same amount of database latch activity. All that fun stuff will be identical. Feel free to test it. And if you find a different result, feel free to share it with me, but you won't find a different result. If first does actually make your query faster, or if first does make that check for an ambiguous record, it's because you didn't specify unique criteria. And that means that you have a potential bug in your code, because sooner or later, somebody is going to create a second record, and then you will have an ambiguous find, and one of those records becomes magical. The classic case of that sort of thing happening is where an application ships with multi-company capability. And they set it up in production, and you got the production instance of things, and that's company number 1, and everything's great. And then somebody adds company 0 as the test or training company, and all of a sudden all sorts of stuff starts breaking, because programmers learned that they didn't need to put the company number in there. They just say find first company, and it worked. Well, all of a sudden there's a new company 0, and now you're getting the wrong records. And that's the case of it always works. So that meant that the programmer didn't want to have to understand why their find statement came up with this error message here. And first just makes it go away. So you're basically finding first faster, but you're returning the wrong record faster, which means that it's infinitely slower, ultimately. Okay. And so that's it for dragging your code from the V4 days into the 90s. Maybe we'll do something to get from the 90s into the 2000s next. But with that, if there are any questions, we can try to take those.
Yes, it's not a real question, but it's a comment from Tim. First can also hide data errors.
What can hide data errors?
The first.
Oh yeah. Yes. That's kind of what I was getting at with, with the comment about the company. It's sort of the same thing. So you're not looking at the data that you think you're looking at. Yeah. It's definitely a bad idea to throw those first statements all over the place.
Yeah, I agree.
Okay.
Any
other questions?
No. Nothing else.
All right, well, I think that's right about on time. So thank you very much. And if you have any questions later, feel free to contact me, tom@wss.com. Thank you.
Thanks for presenting, Tom.
You're welcome.